There we go. Okay. One more moment. Here we go. All right. Again, thank you so much for being here for Wildlife Wednesday with Heidi Pearson, and she'll be discussing humpback whales and tourism in Juneau and what can we learn from the COVID-19 pandemic. Some engagement guidelines for tonight. We do encourage you to keep your mute on and your video off, and that'll really help to preserve bandwidth and to streamline the evening without any interruptions. And if you could view this presentation in full screen mode, you're going to be able to get the entire, the best picture, I should say, of the presentation this evening. And if you have any sort of questions throughout the evening, do throw them into the chat and we will get to them at the last 10 to 15 minutes of tonight's presentation that is solely devoted to Q&A. So we will get to everything at the end. And we just overall hope you have a good time and learn something new and share some information with anyone you know. AWA has been around since 1978. And again, thank you to our members. Without our members, we wouldn't be able to have these presentations free for the public. So thank you so much. And this presentation this evening is part of our Southeast chapter specifically. We do have 3 chapters throughout the state, and this one being out of Juneau, but we also have one out of Kenai and out of Anchorage. The 3 pillars that AWA focuses our work on, we work on citizen science, education, and advocacy. And in citizen science, we do a lot of work helping to monitor the critically endangered Cook Inlet beluga whales out of the Cook Inlet. And we are one of the several partners as part of the Alaska Beluga Monitoring Partnership, or AKBMP. And we co-host with the Kenai Peninsula College the Kenai and Kasilof River monitoring sites. And that picks up this spring between March and May 15th. So if you are interested in starting on March 15th, please reach out to AKBMP. I'll throw their website into the chat after I'm done here, and you can reach out to them to help out. And we also do some education throughout the year. We do some tabling, we do some wildlife walks, and you can see one of our volunteers down in Southeast. Perhaps you've seen our signs on the new electric bus system down in Juneau. So do a wide variety of things there. And then in advocacy, we filed a polar bear lawsuit last fall to help protect the Beaufort Sea population up in the north. And we also have proposal 199 that is moving on to the statewide Board of Game meeting here in March. So that was a proposal we put forth to implement 50-yard trap setbacks off of about 200 trails, multi-use trails, specifically in the Mat-Su Valley. So do all sorts of work. Slides are sticking. Here we go. So some news that we've been up to, there's a whole lot on our website, but recently we are part of a group working to help urge for better protections for beluga whales that are the population in Cook Inlet that are critically endangered. Our vice president has been published in a few articles, and also there's some more information about our proposal 199 to establish the 50-yard trap setbacks in the Mat-Su. And some events we have coming up this month. March is looking very marine oriented for Wildlife Wednesdays, which is fine by me. But we do have a few coming up on the 2nd and 3rd Wednesday of this month as well. And we have spring monitoring that starts for the beluga whales, like I mentioned, for the Kasilof and Kenai River sites that begins on March 15th. And we are having a Kachemak Bay Marine Mammal Forum that we're going to be co-hosting with the Kenai Peninsula College and the U.S. Fish and Wildlife Service down in Homer on April 18th through the 21st. So I'll throw a web link for that as well into the chat, but it is still in development, but we would be happy to see you all there for that. You can watch our past Wildlife Wednesdays on our YouTube website and Facebook page. And our climate adaptation workshop wrapped up last week. It was a success. We had hundreds of people in attendance. Really was fun to connect with folks and learn more. So YouTube has our videos for that as well, if you would like to see what was discussed. And we are the Blue Market charity of choice between January and March in Anchorage this year. And Blue Market is a zero waste group that they're a little new age market, really, really cool market in Anchorage. And if you are around and want to swing by, check them out. And 1% of their proceeds will go to us this quarter. And also, it's still early enough in the year to consider your 2022 calendars. If you haven't gotten one already, there's still plenty of time to do so, and feature some really magnificent photography from some local artists in the state. So, and featuring local Alaskan wildlife. So check out our website for those as well. Thank you again to our members. And if you would like to become a member, it's $35 a year and it is well worth it. All of that goes to a really great cause with some really, really passionate work being done. So, and if you cannot or are not interested in a membership, there's also some ways to support down below. We're Pick, Click, Give organization in Alaska, CFC as well, and Amazon Smile. So a whole bunch of ways to help out wildlife if you're interested. And I'm going to hand it off to Heidi. It's her time to shine, but we're really excited to hear more of what you have to say about humpback whales and tourism in Juneau from the pandemic. Thank you so much.
Thank you, Kelsey. Thanks for that great overview of all the great things that AWA is doing. And I'm very happy to be here tonight. Thanks for inviting me. And thanks to all of you for showing up on a Wednesday night. So I'm going to share my screen and tell you a little bit about the work that we've been doing the past couple of years. So as Kelsey mentioned, the title of my talk is Humpback Whales in Tourism in Juneau. What can we learn from the COVID-19 pandemic? So many of you in Alaska are probably pretty familiar with the humpback whale. And the humpback whales that we have here in Alaska are part of the North Pacific population. And at the last estimate, this population size is believed to be about 20,000 animals, and it's believed to be increasing. So in northern Southeast Alaska, where Juneau is located, we think we have about 1,600 individual humpbacks that come here each summer to feed. And during the winter, they migrate south. Most of them go to Hawaii, but some of them go to Mexico. One of the reasons humpback whales are so fun to watch is because they do all of these interesting kinds of aerial behaviors. They leap or breach out of the water with their whole bodies or just their heads or tails. They also stick their heads straight up out of the water in a spy hop. They can slap their 12-foot long flippers on the surface of the water, making loud sounds that they can be used in communication. And all of these behaviors are actually thought to function in communication. The spy hop, we think that function is more out of curiosity. It's a way for this fully aquatic mammal to break the surface of the water and check out the above water surroundings. And some of these behaviors can also be a form of play or done just for fun. So again, humpback whales are in Juneau and Southeast Alaska and all of Alaska actually during the summer to feed. This is their feeding grounds. So their main job when they're here is to feed. So what are they eating? They are eating a variety of things. What we see here in Juneau is they're usually eating herring, but they also eat pollock, salmon, capelin, and some small invertebrates like krill and other zooplankton. And the important thing to remember is that when they are not on the feeding grounds, when they are on those breeding grounds, they are fasting. They are not eating. So they are really putting on a lot of extra energy and fat reserves when they're up here in Juneau. Some of you have probably seen humpback whale bubble net feeding, which I think is one of the most exciting animal events to witness in all of nature. And we're lucky to have that here in Southeast Alaska. And this is a cooperative behavior that some individuals do. And how this works is that the animals will feed in a group, can be as even single humpback whales can bubble net feed, but sometimes the groups can be 12 or even 20 individuals. And the whales dive under a herring school, and usually one whale creates this bubble net by blowing bubbles out of its blowhole. And then at the same time, the other whales in the group are swimming under and around the herring school. Amidst all this, one whale is giving a loud feeding call, which is thought to scare the herring and make them move more closely together, and which makes it easier for the whale to trap them. So through this process, the herring are encircled by a wall of bubbles, which the whales push towards the surface, and then all of a sudden, this mass of whales will break through the surface and with their mouths open, as you can see here, and they'll take in the water and all of that herring. And of course, humpback whales are what we call baleen whales. So you'll see at the top of the head, the upper jaw, you'll see those baleen plates instead of teeth. And humpback whales can also feed below the water. They're still lunging towards their prey underwater, but it's just subsurface instead of at the surface like we see with bubble net feeding. So in this photo, this was taken a few years ago in North Pass. We have a mom and calf on the left side, and then on the right side, we have another individual. And we think that humpback whales can eat about 2,000 pounds of food per day. So again, they're putting on all of this energy, storing it in their fat or their blubber, and that will sustain them while they are fasting on the breeding grounds for several months. One of the ways that we can get to know individual humpback whales is through their distinctive markings on their flukes or tails. And each humpback has a unique pattern of black and white on the underside of its fluke. That's just like a human fingerprint. Each humpback whale has a unique fluke marking. And so when a whale goes down for a dive, like we see here, we can look at the underside of the fluke and take a photo. And then through time, we get to recognize individuals. And as we continue to take photographs of whales through time, then we can recite these individuals and learn about their movement patterns, their reproductive histories, social patterns. A lot of different things can be learned simply by taking a photo of whales and identifying that whale based on its black and white markings. So here's some photos, and just to give you a little mental game here, see if you can match up the flukes on the left with the flukes on the right. So we use the black and white markings, but also we use the trailing edge or the top edge of the fluke as well. Those bumps also form unique patterns for each whale. So hopefully this wasn't too hard and you were able to match up those two and those two and those two. It's not always this easy, though, especially in Southeast Alaska, where a lot of the flukes tend to be predominantly black. So in my lab, I've been working with humpback whales in Southeast Alaska since 2011, and this is a poster created by my intern Trinity Johnson last summer, and these are the 179 individuals that I have in my catalog at the University of Alaska Southeast. So each of these squares represents an individual humpback whale, and what I get excited about when I see all of these flukes is that each of these is a unique individual with its own story, its own life history, and we're getting to know these stories about these whales through time as we continue to do photo identification in the Juneau area. Another thing that we're starting to look at are the association patterns or friendships that whales form. So whales are very social animals, just like humans are, and we tend to see certain individuals associating with certain individuals more than others. And what we're seeing here are 13 of the more commonly seen whales in the Juneau area. And you can see we know their sex, and they all have a unique ID number. And so this is basically showing the social network. So what is the connectedness between these 13 individuals? You can see they're all connected in some way, but some of them are more connected or more tightly bonded, maybe even better friends than others. And you can see there's 4 individuals on the right side of the graph They're all females, and they're connected by blue lines that are thicker. So the thicker the blue line on this diagram, the tighter the bond. And we're still untangling what all this means, but it is exciting to see that with this initial analysis, it looks like there are some interesting social behaviors and friendships being formed by some of these pretty well-known whales that we have here in Juneau. So we have this wonderful website now called Happy Whale. Some of you might be familiar with this, but Happy Whale is basically a citizen science platform, but researchers use it as well. It's a very powerful platform, and what it does is it allows anyone who takes a photo of a humpback whale fluke to upload it to this site. And then it will do a couple different things. One is it will tell you the ID of that whale. There's an automatic matching algorithm where it will automatically match that whale to thousands of whales in the database. And then it will also tell you where else that whale has been seen. And so, for example, this is one of our well-known whales in Juneau named Flame. She might be the most well-known whale because, according to Happy Whale, she has the most sightings of any whale. And we know from Happy Whale that Flame regularly occurs here in the Juneau area, and then we know that she goes down to Maui during the breeding season. So if you're not familiar with Happy Whale, I encourage you to check it out. And if you're ever on the water and you take a photo of a fluke, you can become your own citizen scientist and match your whale and then start to get updates about your whale as well. So Flame is just one of the many humpbacks that attracts tourists to Juneau, and Juneau is one of the world's premier destinations for whale watching. There are some important benefits to whale watching. So on the economic side, based on a report that collected data in 2019, there were nearly 370,000 whale watching passengers that embarked on one of 68 vessels within one of 20 companies in Juneau. And the size of the whale watching fleet has tripled in the past 20 years. This is a very important industry for Juneau, having a direct economic impact of $38 million a year. And for comparison, this value is greater than the ex-vessel value of Alaska's herring fishery during any of the last 20 years. My students and I have also studied the education and conservation benefits of whale watching. And we found that after a tour, whale watching passengers have increased knowledge of whales, their biology and their conservation, and they also show increased support for regulations to protect whales. So there's clearly economic, education, and conservation benefits to whale watching. The flip side of that, though, is that there are some costs as well. So we have studied the ecological costs of whale watching on humpback whales during a 2-year study in 2016 and 17. And this study was prompted by observations of scenes as are shown here. So this is a photo taken in, I believe it was 2013 in North Pass, which is a pretty popular area for whales in Juneau. And you can see a single whale blow in the middle, and there were at least 13 different whale watching vessels around this whale. So we began to wonder if this vessel pressure has any impacts on the whales. And we found through shore-based observations that there were some changes to whale behavior in response to whale watching vessels. So we found that when whale watching vessels were within 500 meters of a whale, the whale responded by having more frequent direction changes, increasing their travel speed, having shorter dive durations, and faster breathing rates. And while the long-term effects of these behavioral impacts are unknown, it's possible they could lead to decreased feeding efficiency, increased energetic expenditure, or stress, all of which could lead to deleterious health outcomes. So there's regulations and guidelines in place to protect whales in Alaska. In 2001, NOAA established humpback whale viewing regulations to minimize harassment of whales. And the primary component is that vessels must remain at least 100 yards from humpbacks. More recently, NOAA established Whale Sense, which is a voluntary program for commercial whale watching companies that encourages best practices in whale viewing behavior, while also promoting educational and conservation messages. So for example, whale sense vessels are meant to abide by additional approach guidelines to minimize whale disturbance. And in 2019, there were 8 Juneau companies participating in this program. And it's not just whale watching vessels that are encouraged to abide by best practices. All recreational boaters are encouraged to give whales what's called bubble room. So just giving whales space to live their lives and do what they need to do when they're up here on the feeding grounds. Another big thing about being responsible around whales is to try to reduce speeds in whale hotspots in Juneau, which would be places like North Pass and Halibut Cove. Recently, we have documented some evidence of interactions between humpback whales and vessels. So just this past summer in 2021, we documented several cases where whale injuries appeared to be from vessel strikes. Here we see a whale that we nicknamed Helix, and we first photographed this animal on June 22nd, 2021, and it showed no sign of injury. That's a photo on the top left. Then a little over a month later, we photographed Helix again, and it was apparent that it had been struck by a boat. The scarring on the whale's left side is most likely from a boat propeller that hit it and ran from the whale's side up to its dorsal fin. And we know that this is the same whale because of the shape of the dorsal fin is the same. It has this small white scar at the tip of the dorsal fin that you can see at the top photo there, and then also at the bottom photo. So it's important to note that whale watching and vessel traffic are just some of the stressors that humpback whales in Southeast Alaska face. Recently, the marine heat wave of 2013 to 2016, also known as the blob, led to decreased body condition of whales, likely driven by decreased prey availability. The whale in the top left photo is quite thin and has a depression behind its blowholes where you can see that arrow pointing, and this is forming what we call a peanut head. Typically, there should be a smooth body contour of blubber from the head to the dorsal fin. So this depression behind the blowhole indicates that this whale is unusually thin. In Glacier Bay, we know from our colleagues doing work there that there was a severe drop in the number of whales observed, as shown in the bottom left graph, and also the number of calves, as shown in the bottom right graph, in the years during and after that marine heat wave of 2013 to 2016. And it's possible that this decrease in calving rate and number of whales observed was due to decreased prey availability.
This extraordinary year has shown us that wherever we...
I just had a malfunction with my earbuds. I apologize. Let me get back to my presentation. All right, sorry about that. So just to say that there are other stressors that these whales face in Southeast Alaska and globally. So the whale watching traffic that we have here in Juneau is driven by cruise ship passengers. And we know that the growth of the whale watching industry is linked to the growth of the cruise ship industry, as most of the whale watching passengers come from cruise ships. So as you can see in the graph here, there's been a steady growth in the cruise industry over the past 10 years. In 2020, 1.4 million cruise ship passengers were expected in Southeast Alaska, and this was an all-time record high. As 98% of cruise ships in Southeast Alaska stop in Juneau, this number approximates the number of passengers that were expected in Juneau in 2020. And then, of course, that didn't happen because of the coronavirus pandemic. So it's an understatement to say that this pandemic has had and continues to have tragic consequences for human health, economies, societies, and lifestyles. But at the same time, this anthropause has provided the unprecedented and hopefully once in a lifetime opportunity to observe wildlife in the context of reduced movement of humans around the globe. So in Juneau, once it became apparent that some and then all of the cruise ships would be canceled during summer 2020, we realized we had this unique opportunity to assess humpback whales in the near absence of whale watching vessels and vessel traffic nearly altogether. So the bottom figures here show vessel traffic near Juneau during June 2019 and June 2020. And this is based on data from shipboard geographic location systems, which is called automated identification system. And you can see by the lot of pink lines in June 2019 and then virtually nothing in June 2020, that vessel traffic essentially halted. So we realized we had an opportunity to see what these humpback whales were doing during these unusually quiet times. And the BBC got word of our project, and in August 2020, they sent a film crew out to film our work. And that filming resulted in a 3-minute featurette, which I'm going to share with you now. I'm going to stop sharing and switch over here to the 3-minute video.
This extraordinary year has shown us that wherever we step back, the space we leave is providing wildlife with new opportunities.
This pandemic can help us take a step back and assess the relationship that humans want to have with the natural world.
Juneau is a premier whale watching destination. In a typical year, we'll have about 1.3 million people visit by cruise ship. And of those, a quarter of them will board smaller boats to go on whale watching trips. This year, we essentially have 0.
This year is a really incredible opportunity as a scientist to collect data in the absence of a lot of boats on the water that we can then compare to previous and future years of normal whale watching activity.
The number of whale watching boats around a whale increases the amount of sound that a whale is exposed to. Therefore, there's the potential for whales to be more stressed out than they would if they had less disturbance around them.
The goal of the study is to determine what is the stress hormone level of these whales during this unusual year.
What we're looking for is the concentration of a steroid hormone called cortisol, and we recognize this as stress.
Power 2, safety off. Let's try and get a little bit closer.
When we're collecting our data, we believe we have a fairly minimal impact on the whales. So the biopsy samples that we take, I compare that to getting a finger prick at the doctor's office. So it hurts for just a split second, but then after that, you're fine and you forget about it.
We fire this towards the animal. It hits into the side of the animal, and then it bounces off and floats in the water.
It's leaking blubber.
And when we get it, we have skin and blubber in this coring end.
So I'll just hold on to it, you twist.
It's a pretty small sample, a little smaller than eraser end of a pencil.
I think we got it all. Nice job.
Good sample.
Our results might help to inform management regulations and guidelines for humpback whales in Juneau. So perhaps changes to the number of boats around whales, how long boats stay with whales, and overall how many boats are on the water. This moment provides a really unique opportunity to understand the natural state of whales and other wildlife around the globe.
We have an opportunity to slow down a little bit and think about how we interact with wildlife and what that might look like with a little bit more intention.
All right, so that was an introduction to our project, and let me go back to the slideshow. All right, so the aim of our work is, the overall goal is to determine if tourism impacts whales. And with the unusual time of the the pandemic, we are establishing baseline measures of humpback whale residency and health in Juneau, and we break this down into two objectives. So the first objective is to use photo ID to determine how many individuals are present and for how long. And then our second objective is to collect blubber biopsy samples, as you saw in that video, to assess stress and reproductive hormone levels. And the hormones that we've selected for stress are cortisol and corticosterone. And then the reproductive hormones that we're looking at are progesterone and testosterone. So meet the team. You saw us in the video, but here we are again. So this is a collaboration with University of Alaska Southeast, University of Alaska Fairbanks, NOAA Fisheries, Alaska Fisheries Science Center, and NOAA Fisheries Protected Resources Division. And we have a stellar group of humpback whale biologists here in the Juneau area, which really made this project possible because, of course, during the pandemic, especially the early days, no one was traveling. And so we had this great local expertise right here that came together to make this project a success. So Dr. Shannon Atkinson is at University of Alaska Fairbanks, John Moran is at Bay Labs, and then Susie Tierlink is at Protected Resources Division. And hi, Susie, I see you're here in the audience tonight. So our field site is in about a 20-mile radius from Bay, which is the main harbor, the main whale watching harbor in Juneau. And our study site basically encompasses the same area that the whale watch vessels traverse. So as I mentioned previously, photo ID is one of our fundamental research tools where we take photos of the flukes and also the dorsal fins. We're building up a very good dorsal fin catalog as well because not all humpbacks fluke every time they dive. And so being able to recognize them by their dorsal fins, which is always out of the water when they surface, has become a pretty good tool. And then as you saw in the video, we are collecting blubber biopsy samples using a modified crossbow. And as you saw again in the video, this enters the blubber layer of the animal, bounces off, it floats on the surface of the water, and then we retrieve it and get a sample of blubber and skin, which contains really important physiological data that we're interested in analyzing. So the hormones that we're looking at for reproduction are progesterone and testosterone. So progesterone is elevated during ovulation and pregnancy, and it's by looking at elevated progesterone levels that we can get an indication if a female is pregnant. And testosterone in males is responsible for spermatogenesis and secondary sexual characteristics. And we can see elevated testosterone in, say, adolescent males, perhaps, that are basically getting everything all ready to go and ready for the breeding season. And then our stress hormones of interest are cortisol and corticosterone. And these hormones regulate an organism's metabolism and stress response. For example, through a process called gluconeogenesis, these glucocorticoids mobilize energy sources to respond to the stressor at hand. In addition, these hormones are responsible for overall metabolic well-being. To extract the hormones, a stepwise process was used, and these methods were done in Shannon Atkinson's lab at UAF. First, the biopsy samples were cut to weight, and the skin was removed. The next step involved hand homogenization of blubber with ethanol. And then finally, hormone levels were determined using an enzyme immunoassay, which basically means that if there's less color in your vial, it indicates that there's more hormone and vice versa. So I'm going to present on our results from our 2020 field season. We did continue this work in 2021, but we are still analyzing those data. So stay tuned for those data, hopefully in another month or so. In 2020, we started collecting data in mid-May and went through mid-October. We had 32 days on the water, totaling 184 hours of effort. We collected 34 blubber biopsy samples from 24 individuals. 10 of those individuals were rebiopsied more than a month later. So in support of our first objective, we identified a total of 63 adult whales, including 6 mom-calf pairs. And for me personally, that was pretty exciting because 6 is the highest number of mom-calf pairs that I've documented in Juneau since I started work here. And we cited an average of 13 whales per survey. And on average, a given whale remained in Juneau for 39 days, with one whale, ID, her nickname is Tucker. She was present for virtually the entire season. In support of our second objective, we first measured progesterone concentration, as this reproductive hormone can affect stress hormone levels. And it also indicates pregnancy. And progesterone is an order of magnitude higher in pregnant animals and is very easy to identify. So on this graph, the outliers, or those red asterisks at the top of the graph, show elevated progesterone in 5 individuals that we thought were likely pregnant in 2021 when we got a biopsy from them. And then in likely pregnant in 2020. And then in 2021, we confirmed 4 of the 5 of those pregnancies. We actually got documentation of all 5 of those females that we thought were pregnant. 4 of them were confirmed back with a calf. One of them we saw back in Juneau, but she did not have a calf. And then I'll point out that whale Flame, ID 1538, she came back to Juneau in 2021 with a calf, and this was the 3rd year in a row that she was seen with a calf. So usually humpback whales take a year or 2 off from calving, but Flame has come back now 3 years in a row with a calf, and that means that she would have been in 2019, she was both pregnant and lactating at the same time. And so just another special note on Flame, she was featured in a recent NOAA Fisheries web story for Whale Week a couple of weeks ago. And not only did she come back 3 years in a row with a calf, as you can see at the bottom here, she had calves in 19, 20, and 21, but also prior to that in 2013 and 2016. Our first look at the progesterone levels from 2021 indicate that she is most likely pregnant again, which would mean that she would be coming back to Juneau with a calf 4 years in a row, which is almost unheard of in humpback whales. So Flame is a very special whale and seems to be pretty fit and pretty healthy to give birth and to successfully rear all of these calves. So now let's go into the stress results, and this is from 2020. So this graph represents cortisol levels, and each dot represents one whale's stress hormone level. So as you can see, first off, there's a lot of variability among individuals, but there's a few outliers. So those 3 dots at the top of the graph there outside of the gray box. And we need to spend more time learning about these individuals and their life history and what factors could be driving these higher stress levels. And also we're going to be comparing all of these stress levels with our data in 2021, and we were fortunately able to resample many of the same animals in 2020 and 2021, and so that'll give us some good comparisons to help figure out what these stress levels mean. And another thing that we've been documenting is the prey field, because prey can affect stress levels as well. So in 2020 and also in 2021, there seemed to be a pretty healthy prey base. The primary prey that we detected was herring. So it seems that in Juneau anyway, the prey may be recovering from the 2013 to 2016 marine heat wave. So these are some snaps from the echo sounder on board the research boat. So these are basically just images from a fish finder where an acoustic signal is sent down through the water column and it bounces off the seafloor or it bounces off prey. In some cases, it even shows a whale. So in the second panel from the left, you can see that arch shape, that red arch shape, that's actually a whale going under the boat. So we think there's pretty healthy prey base, which we're also going to factor in terms of deciphering what our stress results mean. All right, so as I said, we're still analyzing our data from 2021, but so far we've ID'd at least 40 individuals. Many of the same individuals have come back that we documented in 2020. We documented 4 mother-calf pairs in 2021. So again, we confirmed 4 of the 5 pregnancies that we detected in 2020 and 2021. And we were able to collect 38 blubber biopsy samples on 26 individuals. Some of those individuals were resampled twice. And we're already planning for our next season, hopefully to start in May of this year. And if we can get this 3rd season in hand, that'll give us a pretty powerful analysis to look at variation in the residency patterns and stress and reproductive hormones under 3 different levels of tourism. So 2020 being the lowest level with none to low tourism. 2021, we had a little bit more tourism, but still nothing like pre-pandemic levels. And then 2022, there's indications right now anyway, that it could be back to a high level, perhaps even approaching pre-pandemic levels. And of course, there's a lot that can change between now and then, but hopefully we'll be out there to document it and to put all this together and see what this means for the health of our humpback whales in Juneau. So in summary, we were able to take advantage of the unprecedented opportunity afforded by the very unfortunate events of the COVID-19 pandemic. And we're establishing a solid baseline of residency and reproductive and stress hormone levels. And we'll be able to take, hopefully, as I said, this look at what happens with these variables under different levels of tourism. And then just to sum up, the goal of this research is to help ensure that we have a sustainable whale watching industry in Juneau that's thriving for the whales and the tourists, and an industry that protects the resource upon which it relies. So with that, I thank you for your attention. We have funding from various entities, NOAA Fisheries, Pacific States Marine Fisheries Commission, Alaska IMBRI, and BLAST. And studying whales is hard. It takes a big team, and we have lots of folks to thank that have continued to help make this work possible. And I will stop there, and I'm happy to answer any questions. Thank you so much for your attention.
Thank you, Heidi. Wow, the work that you're doing, it's cool to just see how it'll be able to progress in the next few years, like you said, 2021, 2022. And your photographs are amazing, and that video like almost brings tears to my eyes. It was just so well done. So thank you for sharing that. It was amazing. Let's see, you have several questions popping in. If you have any questions for Heidi, throw them into the chat and we will get to them if we can. And let's see here. So we had one that was asking, do you think the decrease in bubble net feeding in Juneau might be because of the increasing tour vessels in the area?
That is actually a question that I've thought about, and I'm just going to share with you my hypothesis, which has not been tested. I think it might more have to do with the prey availability. And so during the marine heat wave, the prey field was decreased throughout Southeast, and it's my hunch that perhaps those bubble netters had to move further in search of food. And it was during like 14, 15, 16, 17, we would get bubble net feeders pretty regularly in the Juneau area. But I haven't seen them in the Juneau area in my study site since 2018. So in 2021, when we didn't have as many vessels, there were no bubble net feeders, but I know they're around. My colleagues at Alaska Whale Foundation that study further south of Juneau and Chatham Strait, we know the bubble net feeders are down there. So I'm thinking it might be more likely linked to prey distribution, and that now that the prey is rebounded, they don't have to travel as far and are staying down in that Chatham Strait area where they tend to hang out. Anyway, just a hunch, and it'd be great to do some further study to actually verify that.
One more good reason to get out on a boat in the summer. Was it known if the drop in Glacier Bay whales was a range shift with those whales going somewhere else, or was it a population decline that accounted for the decrease?
That is a great question. And so that work has been done by my colleagues Chris Gabriel and Janet Nielsen in Glacier Bay. But after talking with them and other researchers throughout Southeast, they believe it is a true decline as far as I know. So through networks like Happy Whale, we have a pretty good record of these whales in Southeast Alaska. And we do believe that there are some whales that are counted as missing, and perhaps they perished during the marine heat wave. So they do believe it is a true decline. We do collaborate across Southeast Alaska. We're sharing images as well, in addition to Happy Whale, and those whales, for example, haven't turned up in Juneau. So it's likely that they did, they could have perished.
Thank you. Someone asked briefly, can you confirm Riddler's sex from your social connections graph? Got cut up on their screen, but they were curious.
Oh, sorry about that. Yeah, Riddler's a male. I kind of call, just very anthropomorphizing, I call Riddler a ladies' man because he tends to like to hang out with females a lot based on my observations.
In that vein, other than association with a calf, how are you determining sex? Or is it in association with a calf, how you determine the sex of the whale?
We have two ways. So when it is sighted, when a whale is sighted repeatedly with a calf, we know it's a female, and especially if it's resighted year after year or multiple years with a calf, we can be pretty certain it's a female. But the cool thing now is with our blubber biopsy samples, we send a part of that blubber off to a lab at Oregon State, actually, and they can give us the genetic sex. And fortunately, that genetic sexing has confirmed the sexing that we've done in the field based on individuals having calves.
Do you know if Flame's previous calves survived, or was each subsequent pregnancy perhaps due to her prior calves not surviving?
We don't have data on that as far as I know. And that's a question it would be great to get out, for example, through Happy Whale. But as far as I know, we don't have solid photo ID data on the calves after they have been weaned. And that's certainly a possibility that she started being reproductively receptive again if she lost a calf, but it's hard to know at this point.
Speaking of sharing information, are you sharing information on the Juneau whales with researchers in Hawaii? Do we know if all the Juneau whales go to Hawaii, or do some go to Mexico?
Yes, we do collaborate with Hawaiian colleagues quite regularly. Shannon Atkinson, one of the co-PIs on the project, has also done blubber biopsy work with looking at hormones in Hawaii. So yes, we collaborate quite closely with them. And we know through Happy Whale, again, that most of the Juneau whales go to Hawaii, but some of them go to Mexico. And and then we also had, before we had Happy Whale, we had like this big collaborative study called Splash, that was done in the mid-2000s, which also provided some evidence of those migration patterns. So that was a long way of saying that, yes, we do collaborate with Hawaiian folks.
Great. Do you know off the top of your head who the higher stressed individual whales are?
I do not know.
Do you keep them ID'd by number in your data, or do you go with names on how the public knows them, or how do they get ID'd?
We always use, so in our database, we always use as the primary identifier the number. So the number is a unique identifier. across research groups. And then the nicknames just help us to remember them better, I guess, because it might be easier to remember kelp, for example, than his long, like 8-digit letter and number name. So scientifically, we always rely on the ID number, and in publications we do as well. But when we're talking more informally and to the public and things like that, then oftentimes we'll use their nicknames.
I used to work in whale watching in the past down in Washington, and same thing, we would give people an ID number, like J26, but then we would always give them their kind of famous regular name, like Mike. It gets people a little bit more engaged, especially if they're not maybe into science as much. If they're just excited to see whales, it's helpful to have a casual name like that.
Right.
Builds connections. If it is determined that boats cause whales stress, what could be done given this is a profitable industry? Great question.
Yes, that is, I mean, that's $1 million question here. So we want to make sure that any management decisions are based on best available science. And so that's what this project is intended to do. And as you can see on this screen, NOAA Fisheries is a partner and a funder of this work. So clearly they want to know what's going on. And what can be done remains to be seen. But I can say that I know it's in the best interest of everyone to ensure the sustainability of the industry.
I'm sure it would, yeah, be a big collaborative answer. Can you collect the same data using eDNA rather than a DART sample?
At this time, no. The eDNA work is still very early days for cetaceans, and I honestly don't know if it's been worked out yet for humpback whales. It has to be done species by species. And so eDNA is, as its name implies, is looking at genetic material, DNA, and that would not give us information on hormone levels because these hormones are circulating throughout the body, and then they're deposited in whales. They're deposited in that fatty blubber layer, and those hormones aren't going to be shed into the water like DNA would. So with eDNA, we could potentially get genetic information, perhaps get sex, some other genetic information, but as far as the hormones, we couldn't get that from eDNA.
Would Scat be in the same lines or no?
Scat, you can extract hormones from Scat, and it has been done successfully for right whales, for example. You can get reproductive and stress hormones from Scat, but it's pretty hard to collect Scat on humpback whales in Juneau. One of the reasons being that they are primarily feeding on fish when they're here, and just to get a little bit gory on you, when they're eating fish, their Scat tends to be heavier and it sinks, whereas if they're feeding on krill, their Scat tends to be more buoyant and float at the surface. And so I'm always looking for whale poop, and it's pretty hard to find. So that would be a totally non-invasive or nearly non-invasive method, but it's just so hard to get. You wouldn't be able to get nearly the sample size as you could with the biopsies.
Mm-hmm. There, down in Washington, there's a poop sniffing dog, and it hangs out at the front of the boat, and
Yes.
it smells it out, has its little goggles. But I can imagine a lot goes into making that happen.
Yes.
Yes. Do you know the time frame over which an elevated stress level represents?
Yes, we're getting more information on this. So typically, we think it represents the average stress level of a whale over a period of weeks to months. And I know that's very broad, but we even think it might be on the order of days. So Shannon Atkinson has some data that suggests it could be around 9 days or so. So it's definitely not an instantaneous measure, but it's this average level over the course of, I think we could probably be fairly safe to say, the past weeks of that whale's life.
Very interesting. Let's see here. Are the whales in Juneau catalog, with Happy Whale and PWF IDs going to get Seek IDs anytime soon? Will that be included in the new version? I don't know if that's directed. It says Susie if you're reading, so maybe that was more for Susie, but if you can speak to it as well.
Yeah, well, I know that having the Southeast Alaska IDs is the goal for those, and it's part of the naming process that actually I think Happy Whale is helping to coordinate at this point.
Do you want me to chime in, Heidi?
Sure.
Sure. Yeah. So the convention of naming for the Southeast catalog is that there has to be multiple sightings, and they have to have multiple sightings post calf years. So there can't be a calf that gets its own ID number. It sort of lives under its mother's ID number for a little while. And you know, when it comes to collaborating and Happy Whale, we have you know, sometimes we catalog things with Happy Whale, sometimes without Southeast, and it just creates confusion. And sometimes they get Southeast Alaska numbers, which are shorter, easier to work with, but it doesn't always work out that way. And once we have the chance to incorporate them into the Southeast catalog, they'll get numbers, but it's not always a quick process. And we know that the longer numbers are harder to work with, but sometimes it's just the easiest way to work with things. And we know that, you know, we can call them by different names, and that we know which whale we're talking about. So hopefully in time, we'll kind of condense them down and get those Southeast Alaska numbers.
Wonderful, thank you. I think that, do you have anything else to add to that, Heidi?
I don't. No, that was a great answer. Thank you.
Well, we have one more question. It is 8 o'clock on the nose. Heidi, if you would like, we can cover that last one, and then I think we'll wrap it up.
Sure, that's fine.
All right. Are you able to relate stress with vital rates, specifically age-specific increases in mortality or birth rates? My experience suggests that man-induced wildlife stress studies are notoriously difficult to parse out stress from other factors like food or habitat, etc.
Yes, and I'm actually looking at that in the chat as well. You are correct that stress can vary in an individual based on many different factors, and so we're trying to control for as many of those factors as we can. So we are getting the reproductive hormones because we know that progesterone and testosterone could have an impact on their stress level. So we're going to control for that in our analysis. And we're also assessing the prey field as well, because prey could have an impact. There could be other factors. I mean, I know there's other factors that are going to affect stress that we just aren't going to be able to capture in this study. So what we'll do is we'll do a rigorous multivariate analysis when we're looking at our statistics to try to incorporate as many of these possible explanations into our model as possible.
All right, wonderful, thank you. And that wraps it up for our Q&A and for Wildlife Wednesday in general. It's 8 o'clock. Thank you so much, Heidi. I again want to remind everyone that Heidi was here volunteering her time. And so we're very grateful to hear this really cool information. And it's exciting to think that some new discoveries are going to pop up in the next few years. Really excited to touch base and to keep updated on that. So yeah, thank you. And we appreciate you doing the work that you're doing. And thank you all for attending. You can throw your kudos into the chat and we'll wrap up our recording here in just a moment, but I do want to remind everyone that this recording will get added to our website and our YouTube channel and also our Facebook page. And I typically do that the day following, so hopefully tomorrow. But thank you all again so much. I appreciate having everyone here, especially you, Heidi.
Thank you so much. You're welcome. Thanks so much, Kelsey.
Of course. Have a good evening, everyone.